안녕하세요. My name is Raviv, and today we're going to talk about DevSecOps and our learning from our research in ING. About ING, according to Forbes, we have been a leading digital bank for the past few years. In fact, we invented internet banking. In order to keep up with technological advancements, we became fully agile, following the Spotify model of tribes, chapters, and squads. We have thousands of engineers, but not enough security professionals. So we had to shift security over to our developers. We're moving DevOps to the cloud, but without banking data, due, of course, to the many regulations surrounding our business. So a little about me. I've been in this industry for 20 years now, with specialization in application security. I served in various roles, from being a hacker for hire, through team lead, CTO, inventor with 2 patents in network access control and web behavior analytics, and security architect. I've lectured and blogged, coded open source attack tools, and my claim to fame is actually featured on the first episode of the TV show Mr. Robot, where they use a tool I created called Are You Dead Yet, or Rudy for short, that launches application level denial of service attacks using slow HTTP posted requests. So our topic of today, software is eating the world. Software is the fastest growing industry in human history. There are an estimated 27 million programmers worldwide now, producing 10 lines of code per day. That is about 64.8 billion lines of code per year. Most of it is heavily based on third-party libraries, which are usually open source code. Now, we're a truly global village working together using collaboration tools such as GitHub. Our software is diverse in language and technology, and we mesh it all together in containers, microservices, and web API. We serve our customers more and more over the cloud with software as a service, and even banks are now becoming utility services thanks to the Open Banking Initiative. We've experimented with building the ideal security pipeline here at ING, exploring the pros and cons of fully automated DevSecOps. This means that from the moment a developer pushes code, it is incrementally scanned by SAST, the libraries are inspected by SCA, the built containers publish an Open API interface, which is used to locate and attack every API endpoint with relevant payloads. And we even tested advanced IAST, which is interactive application security testing, with remote API to retrieve alerts and then compare them with the other security testing layers. We researched the ability to aggregate and correlate different alert systems such as CVE, CWE, and natural language descriptions. We found out the deep pain engineers are faced with is basically triaging alerts. Every vendor has its own scoring and reporting database. Every tool has its pitfalls, and without intelligent analysis, human or else, this creates more problems than solutions. So we talked to tens of other same-size companies and came to several industry-wide conclusions, which I will now share with you. So about application security testing, we have static, dynamic, interactive, and dependency security scanners. Then there are also emerging vendors offering alert aggregation and governance. All basically stack and shift left a plethora of false positive alerts. This is without taking into account the false negative ones that the end users are unaware of. We scientifically measured SAST results based on human feedback. We found out that out of the box, without any fine-tuning, more than 90% of the time, the best tools get it wrong. Nonlinear data and control flows become over-complex for rule-based systems to follow. Mitigation functionality is often missed along the way, and there's a lack of context per project that leads to excessive false positive rates. Dynamic attack tools cannot reach deep enough, lack business logic comprehension, and have no insight on the back-end workings of applications. Most times, they barely scratch the iceberg's surface. They either use old-school web crawling techniques or need a lot of guidance to map out the attack surface. So without human interaction As is the case in automated pipelines, these tools lead to high false negative alert rates. Dependency scanners are usually glorified hash-based scanners similar to first-generation antivirus software. They also lack application context. They can report whether they identified a library with a known CV, but cannot tell whether a sublibrary recursively poses a threat in a real attack vector. Then last but not least, we have the youngest technology of the stack, interactive application security testing. Through live instrumentation, such as implementing a Java agent, they can reach high precision. They track the real-time data flow and verify attack vectors. The only problem security-wise is that they are rule-based and can detect only what their database of rules tells them. Another business problem is the high cost of maintenance and disruption of production-grade environments. And so in spite of their security advantages, we have not seen this technology widely adopted in the market yet. So what does shifting left look like in a highly regulated industry? Can we really keep up with regulation requirements such as GDPR while keeping agile? This is more or less the picture we got from the market. Developers review alerts, either in SaaS SCA ticketing systems or pull requests, and attempt to identify relevant ones. Developers consequentially review snippets of code reported as vulnerable to validate alerts, tracking data flows to find real attack vectors. Then developers report to security experts and wait for further instructions. The security teams review code, look at the context of the application and alerts, and determine the resolution. Then the security teams either advise remediation back to the programmers or decide on a ticket resolution in case it's a false alarm. Developers then pop remediation items from backlog queue and spend sprints fixing code and dependencies. Then IT security compliance is checked by several authorities to approve changes to production, taking into account security and privacy considerations. And then finally, a merge request is made. So if our engineers' time is at least 1 to 2 sprints spent on security triage, we're talking tens of thousands of development hours spent only on security and compliance, and approximately 10% of that time is worthwhile, given the high rates of false positives in security systems. We found out big organizations tend to manage security and compliance information across decoupled systems, distributed over different countries. Gaps in standard formats and inter-system accessibility create a fractured process with low oversight visibility. So basically, the data is distributed in silos. It is typical to see one security expert per 100 developers. Security champion programs are in their infancy, and it takes years to train good developers to be good application security experts. So the eternal dilemma is either to release not so secure code versus holding back the new version in favor of security constructions. So how does one keep agile and secure at the same time? We break it down to project or team responsibilities. We constantly train and challenge our engineers. We assign security champions per team and continuously assess their levels of security maturity. Mission-critical systems are assigned dedicated security teams. The future of cloud operations does look promising. We've seen functional tests being generated by AI. Evolutionary algorithms allow better fuzzing and adaptation of payloads to find vulnerabilities in dynamic testing. We will see more automated pull requests coming in from intelligent bots suggesting remediation in code. We've even seen some vendors promising to profile the developers over time and monitor their security maturity, kind of like a developer's big brother system. How can you change your organization for better? Well, knowledge is a never-changing rare resource in the tech industry. After you find a solution yourself, teach your peers those useful tricks. Arrange team meetings where each member teaches the others on one domain they learned about recently. When faced with the choice of writing code from scratch versus the use of existing mature frameworks, always opt to work with a known and preferably open source framework. Many eyes have reviewed the code, and vulnerabilities have a better chance of being uncovered. Modern frameworks also take care of enterprise security features, such as input validation, user authentication, authorization, session management, and access control. And finally, always wear your black hat when you're thinking about your strategy. So think like the criminals and try to think of every possible breach.